Today's video is over the law of sine. This may be review for some of y'all because this was covered in geometry. So the law of sine is used for triangles that are not right triangles, which means they must have an obtuse angle, which is an angle that's bigger than 90 degrees. And the way that you can use law of sine is in three particular situations. When you're either given the angle, and side, the angle, side, angle, or the side, side, angle. The order in which these three letters are written is really important because what this means is that this side right here is not located between these two angles. And in this situation, this angle is not located between these two sides. But this side is located between these two angles. So it has to be in this particular order. Now looking at the formula, as you can see, there's three ratios set up, and each ratio is a relationship between the sine of the angle and the side length. So if we take a look over here at our triangle, this is referring to angle A, which is directly across from side length A. So sine of angle A over side length A is going to be equal to sine of angle B over side length B, which is equal to sine of angle C over side length C. So there's a relationship between the angle and the side length of each side of the triangle. So let's go ahead and work a word problem using the law of sine. So here we have our word problem. Let's go ahead and look for important information. From a certain distance, the angle of elevation, so angle of elevation to the top of a light pole is 18 degrees. At a point 3 feet closer, so we have an important distance here, to the light pole, the angle of elevation is 40 degrees. So again, angle of elevation, 40 degrees. Find the height of the light pole. So we want the height of the light pole. What we should realize when we draw this picture is that we have two triangles. We have an obtuse triangle located right here, and then we have a right triangle located right here. So my game plan is going to be find the side that both of these triangles share in common, and then use that information with SOHCAHTOA to find the height of the light pole. So I'm going to find this side right here, which we'll call Z, and then I'm going to use that information to help me find X. So looking at the obtuse triangle, we know we want to use the law of sine, and we can only use the law of sine if we have a pair of angle and sides that we can use to set up a ratio. So here for side Z, I have this matching angle A. And the side length that we have is right down here, which means I want to find this angle right here in order to set up the ratios. So I can actually figure out what all three angles are in this triangle because we know that a flat horizontal line is equal to 180 degrees. So if this line is divided into two by this angle, I can simply just subtract 40 degrees from 180, giving me the other angle, which is 140 degrees. And now we also know all three angles in a triangle are equal to 180 degrees. So this top angle right here is simply just equal to 180 degrees minus 140 minus 18, which gives me my resulting angle of 22 degrees. So now I can start setting up my ratios according to the law of sine, but I'm going to start by using the information I know. So I know this side length right here, and I also know this angle right here. So I'm going to start with that ratio. So according to the law of sine, I know that sine of 22 degrees over 3 is going to equal to, and this is where I go in and start adding in information that I want. So I want side length Z, and I have the angle that's directly across from that, which is 18 degrees. So I'm going to say is equal to sine of 18 degrees over z. Now I simply just have to solve this to get me what z equals. So an easy way of doing that is cross multiplying the two. And now I simply just have to solve for z by dividing both sides by sine. And so now, once I plug this into the calculator, I see that z is equal to 2.47 feet. So now that I have z and I have this 40-degree angle, and I know that this is a right triangle, I can use SOHCAHTOA to figure out what x is equal to. So I know that x is the opposite side of the triangle, and I also know that z is the hypotenuse. So I can put all of this together and use sine, which is opposite over hypotenuse. And I can plug in all the information. So sine of 40 degrees is equal to x, which is what we're interested in, all of this divided by z, which is 2.47 feet. So now I'm just going to do some simple algebra, multiply both sides by 2.47. Which cancels it here. And so x is equal to my final answer, which is 1.59 feet. So following this video are, I think, 6 problems using the law of sine. Make sure you refer back to your notes that you took in your journal over this video and go ahead and attempt these questions.